the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, good day to all around the globe who are connected for this great session. For those who don't know me, I'm Jacques Biot. I'm the former president of École Polytechnique and now chairman of the board of Huawei Technologies in France. And it's my great pleasure to introduce a presentation by Dr. Ebtesam Almazrouei, who is director of the AI Cross Center Unit at Abu Dhabi's Technology Innovation Institute, TII. In this capacity, she is responsible for overseeing the unit's mandate of designing and delivering new AI methodologies, technologies, solutions, and systems that address core challenges across multiple sectors of the economy. Besides her role, she's the acting principal researcher for the Perception and Fusion team and the acting principal researcher for the Extreme AI Scale team. Dr. Almazrouei co-leads the working group on big data in the AI expert group subcommittee of the UAE Council for AI and blockchain. Also, she's selected to be a member of the worldwide steering board of the Wireless World Research Forum. Dr. Ebtesam Almazrouei led the team behind building Noor, the world's largest Arabic natural language processing model to date, and she is the first Emirati woman to hold a PhD in artificial intelligence for wireless communication, engineering, and computer science. She is a scientific author, entrepreneur, and public speaker. In June, she was among the speakers at the AI Summit in London. She obtained her PhD and Master in Science in Electrical and Computer Engineering from Khalifa University of Science and Technology and earned a Bachelor of Science in Communication and Electrical Engineering from the United Arab Emirates University. Dr. Ebtesam Almazrouei is an extremely promising scientist, and I'm sure you will take great pleasure and learn a lot from listening to her presentation. Ebtesam, the floor is yours now.
Thank you, Jack. I hope my voice is clear for everyone. It's my pleasure to be with you today in this event. Thank you for ITU and AI for Good to organizing these seminars, and so everyone will be can take the benefit and the knowledge that we are sharing among and between our colleagues and researchers and scientists, and also the audience here. Thank you, Jack, for the introduction. And let's start. Let me share my screen. So today, in today's presentation, we'll talk about AI energy bill of extreme scale language models and how it will impact the future of green AI. First of all, we'll talk in general. I will give you a general introduction, giving the background of the audience here. What is extreme scale AI model, how it is connected to the revolution of AI. Then we will talk about Noor, the largest Arabic language model up to date that has been developed by TII team here in UAE. And what we did in Noor, we were considering as well the sustainable aspect and how it will affect as well the carbon footprint in general. So we had an idea, what about doing a holistic assessment of carbon footprint for large language model? And we started with the Noor, and hopefully all the AI community today will be inspired and they can follow our leads and assessing any AI revolution and algorithm they propose. Then we will conclude our presentation with general remarks and how we can impact and towards green AI. So just to give the audience general introduction about Technology Innovation Institute. So Technology Innovation Institute is Applied Research Center. It is the research arm of Advanced Technology Research Council here in UAE. Our main objective in TII is we want to position Abu Dhabi and UAE as a world-class research and development institute. We have more than 60 international nationalities from scientific researchers. They are working on applied research from directed energy, cryptography, quantum, AI, digital telecom, biotech, renewable energy. And in all of these research centers or different scientific sector that we are talking or considering and studying them, the sustainability is a key element that we always keen to address and study it in different research topic and developments development sectors. So what has been done so far and how UAE positioned herself in the sustainable development goal? Of course, we were happy to contribute towards the sustainable development goal, and UAE always committed towards having her commitment into action. There are a lot of sustainability development initiative here has been done since maybe 2017 or even before, and we are trying to consider all of the aspects towards achieving the sustainable system around the world. Of course, as I mentioned, we have 10 research centers, and we heavily investigate the sustainable developments, the climate change. In fact, UAE will host COP28. So how we can study the scientific and in the advancement in the technology and the revolution in the technology and the effect and link it and study also the carbon footprint towards having a sustainable ecosystem around the world, how we can use the advanced technology and the AI in healthcare issue, education, energy, and so on. Of course, just a general background about the evolution of the AI. So the evolution of the AI started maybe at the beginning of 1950. And then it evolves heavily, and with the emerging of many algorithms that has been developed by our colleagues, the scientific colleagues and the researcher, also the industrial leader who are working on the AI from Facebook, DeepMind, Google. Everyone is going towards the super era of AI, and how we can achieve the super era of AI and how it will affect and impact the human life. This is what we are trying to consider it. So whatever you experience today in the AI is what we call narrow AI. It is basically the AI algorithm, the machine learning algorithm, despite the type of it, we are trying to apply it for a specific domain. And this is what exactly you are seeing today from in various applications, from speech recognition to image detection, vision detection. But towards general intelligence, we are seeking that the robotics and the machine, they will be able to plan and reason like us as a human. So in order for us to mimic the human intelligence, not only to replace the human, so this is far from my realm today to study it here and to talk about it, but how we can benefit from the evolution of AI, how we can build strong AI algorithms and models that will be implemented in the machine, in the robotics, and the robotics, the machine, they will be able to plan and think like us as a human. And here, what we call it about the super AI or the general intelligence, where the machines, they will be able to, they will have the awareness about what's happening around them. And the main key aspect towards achieving general intelligence is a large language model. So for us today as a human, the only way to communicate, as today I am speaking to you, is by language. And you can receive my information because I am speaking an international language, and most of the people around the world, they are speaking. So the machine tomorrow, in the future, in order for us as a human to communicate with them, we need to communicate them with a language. Most of the people or the countries around the world, they studied NLP, natural language processing for English. Now, for example, here in UAE, we already study the Arabic language. There is the Sweden language or multilingual model as well. And the importance of this, because we don't need also to only to communicate with the machines, but we need the machine to understand exactly what we are trying to say, or what we want to take an action, or what exactly we are asking. Today, for example, you go to Google and then you put a simple question, and then, for example, let's say you ask Google what is the capital of UAE. And then it will output for you the answer. But for the machine, maybe I want to deal with them as a human, or what we call it a humanoid machine. That in general, the machine, they know that I am interested about UAE, and maybe I mentioned at the beginning something about UAE, and then when I ask the machine or the robot in front of me what is the capital of UAE, no need for me to say what is the capital of UAE. I can only say what is the capital of it, and then they can refer to it because they are planning and reasoning and connecting everything, and they are aware of that subject. This is what we are trying in the AI community to fill this gap, and how we can fill it is by studying the extreme scale AI model or the large language model. It is not a new subject, and in fact, there is a lot of evolution starts with the NLP after introducing the transformer. I will not go deeply through the scientific architecture of the transformer, but once our colleagues introduced the transformer and attention mechanism, the revolution of large language model kick, and there is big communities and companies, they are working around this topic, such as Big Science, Deep Mind, TII here, a lot of Google, Facebook, all of them, they are considering and working on the same subject. And you can see here, for example, in the picture, as I told you before, that the natural language processing have been developed, and the scale of that model has been doubled every 3 to 4 months, thanks for the capacity that is existing for the AI accelerator and the compute budget that is available by different provider that allows us as a scientist to perform this and to perform this computation, and also to develop such large language model. Some of example for the large language model is GPT-3, Jurassic, for example, Megatron, and recently Palm as well is introduced as the largest English model with 540 billion parameters. So as there are different architecture for this for the developed model. For example, for Noor model, we consider only decoders, transformers. For BERT, it is based on encoder only. For GPT-3, it's decoder only. And why I am talking about the architecture of the model? Because the architecture of the model it impacts how the computational cost, and later on during my presentation you will see the link between the model architecture and the computational budget and the carbon footprint for everyone. So it is important for us as a scientist, we have to consider how we can reduce the carbon footprint for AI. So most of the researcher or the global trend, yes, AI could be implemented in a general in a general topic. For example, we can consider using AI, how we can deploy AI technology, for example, and then it will estimate the consumption in the air. And then based on the estimation, we can predict and take an action, for example, to reduce for example, the mobility in this country. Maybe with using the autonomous driving, for example, the human, he is not there. So there are many aspects that the AI development could be applied, and it could reduce the carbon footprint. But until now, the lack for the study of the carbon footprint for such AI algorithm still is lacking. There are rare community who are reporting the actual AI algorithms consumption and how much the carbon footprint that we consume in order to develop such AI algorithm. So before we start talking about how we did the analysis for Noor, which is the large language model for Arabic language built by our researcher here in TII, our main goal is we want to achieve similar state of art for GPT-3 model, and Noor will become the reference language model for Arabic, and then we can use it in the future for summarization, as a narrator application, as a chatbot application, and to empower the usage for Arabic language model, not only the English one. So just to give you some examples about the importance of this model and how it can impact and how we can use it in our daily life. For example, here is an example. It's for the narrator. Let me play this slide and take this one. Here I am asking the machine or the Noor model, not a machine, the Noor model, to generate a text, a general text about football. So but in Arabic, obviously here, because it's an Arabic language, so I tell him, okay, I need, I wrote football, and then he wrote for me a text. And this is very important because sometimes we need to write a paragraph about a subject, and we don't have a time, for example, to write it, or we need to know about certain events. We have just to write the name of that event, and then Noor model will be able to populate the information and generate a text. And it is not similar to the web face. It is totally generated by Noor model itself. it's as if you are talking to a human and you are asking the human to talk more about the football. Then that human who's called Noor, he will be able to talk about football in general. There is another also example, which is the chatbot. I mentioned it earlier. So here, for example, I am asking the Noor to help me, and then I told him I need to know more information about United Arab Emirates. Then of course Noor said, okay, I know everything about United Arab Emirates. And then I started asking Noor, what is the capital? It says Abu Dhabi. Who is the founder? It says His Highness Zayed bin Sultan Al Nahyan. And you can notice here that I didn't say what is the capital of the UAE, I say what is the capital. So already Noor model, he already has the awareness that Ebtesam is interested in knowing information about UAE. So whatever question I will ask Noor, he will answer the question because he already has the awareness about that subject. And there is another application, it's called summarization, and this is very important. For example, here I am asking Noor to summarize for me something I think the first example is related to football, Real Madrid. And then I have very big paragraph about Real Madrid, and this is very important. We can use it as a use case. For example, when you have a certain event, a lot of information that it's fed, for example, in the system, and you don't have the people or the human, they can write all of the, they can read all of these text that's coming to the machine, then you can use Noor model to summarize all the text that is coming and give you only what is exactly you need to know about, for example, Real Madrid. Let me go to the other example. And here, for example, I was interested to summarize a text about the pollution in the environment, how it is affected, and it is, for example, around 500 words, but maybe some of my colleagues, they fit the machine with this information, but I need to take a certain decision and to understand exactly what is happening. So exactly, he told me that, and so the summary or the result summary for Noor is the human is the main cause for the pollution in the environment, and he has to change his behavior in order to protect the environment, and so we can have sustainable ecosystem. So now we know the importance of this large language model, and we are going through this super AI era. How we can reduce the carbon footprint for our AI algorithms. So in TII, we are what we did the holistic assessment from the beginning, not only including the training phase of the AI model or large language model, but also we consider end-to-end the carbon footprint for Noor. And currently, until now, there is a rare community who are reporting the carbon footprint for any algorithms. And I encourage them today, whatever you are producing or developing as an AI algorithm, you have to report how much the carbon footprint for this AI algorithm, not only in the training phase, because the most consumption and the carbon footprint, it will come through the inferences. When I run this AI algorithm through my edge devices, there is a real inferences time, how much it will cost. And the larger the model it is, it's linearly correlated with the energy and carbon footprint. So what are the factors that we can consider today in studying the AI large-scale model footprint, and we have a concrete and a solid and accurate reporting for the estimation for each carbon emission from my AI algorithm. So the first thing that we have to consider the model size. So this large language model, the more it is becoming bigger, and it is related to the optimal performance. So now recently, one is 540 billion parameters. Before that is Megatron 530 billion parameters. And this is a huge amount of billion of the tokens that has been generated and running in the inference. And it costs a lot of energy and carbon emission related to the data size and the tokens that each model have. So what is the best or optimal performance that I can get, and at the same time I can maintain the performance of my algorithm? So far, for example, there is a new scaling law different than the old scaling law that's change or give you the ratio between the data side and the number of the epochs and the computing budget. And maybe in the end of the session, maybe we can go more if you are interested, and we discuss what are the scaling laws and how it is impacting the optimal performance for each large language model. Another aspect also we need to consider, we are running this large language model, but where we are running them. So the hardware characteristics plays an important factor. The number of the flops that it's required in training, and these models are what is the nominal power. For example, the energy consumption for V100, it's different than the energy consumption of the recent release of the H100 or over 100 by NVIDIA. Is TPU is better than the GPU? Up to the recent reports from our scientific, they said that the TPU, GPU, CPU, or at least the TPU, GPU, most of them, they have the, using or consuming the same energy consumption. So what we can use in terms of hardware are characteristic that it could impact and reduce the carbon footprint. Also, another third important factor is the efficiency of the data center. The data center, we measuring their efficiency using the power usage effectiveness, BUE, and usually the consumption of different data center, or the average consumption of different data center around the world is 1.8. And comparing to Google Cloud, they have a data center which is running by 1.1. Maybe you don't see the factor, but if we have an average data center is running with 1.1, we can reduce 39 of the carbon footprint comparing to the average BUE for our data center. Another important as well factor is where is this data center is located. What is the energy supply mix? Is it running on renewable energy? Is it running to using gas or coal? Or where is the location, for example? Because the energy supply mix for different countries changes. So for me as a scientist, if I am considering, for example, the carbon, and I want to have a sustainable AI algorithm where I can do the training or inferences, what is the country that I can train my model, run the inferences, and it has the lowest BUE, and also the energy supply matrix, and how I can correlate it to the carbon emission is really low. These are very important factors that we have to consider in studying our extreme scale model. And in general, this is so the previous factor, it was about the factors of the energy consumption. Now we'll talk about the sources. In order for me as a scientist to develop extreme scale model, I'm going through different phases. For example, I have a huge data. for us as in AI community, we have a huge data. So where we can store this data, the storage and the transfer cost. For example, for me, if I'm storing my data in Amazon WS, for example, in Bahrain, it will cost the transferring that data to UAE. It will cost more in terms of the energy if the data center is located here in UAE. And all of these analyses, we take it into consideration in our assessment for the carbon footprint for Noor. Also, how much data I can store. Can I store it, for example, in a premise, or it's better for me to store it in a cloud? Not only the data, but also the experimentation. Because before, for me as a scientist, before developing any algorithm, I run through, for example, processing, reprocessing the data filtration, data curation, the fine-tuning parameters for my model until I get the right performance. So all of these also is an extra source for the carbon emission footprint for our large language model. Now we will go after experimentation. I need now to train the model. So of course, training the final model, for example, maybe it will train for 1 month, 2 months, depends on the computational budget and the number of the GPUs that I am running my algorithm in. Also, it will contribute to the carbon footprint. Now I already finished from the training. Now I need to serve this model. Now I have the optimal, for example, we have Noor, where we can serve Noor as a model. So the people, when they will test the model, or they will have the results from Noor, they will use it through API. This API, where it is located, in which country, is it better for me to be based here in UAE? How many tokens I am using to run these inferences? This is all important sources for the carbon footprint for Noor, our large language model, and any other language model is developed around the world. Also, there is an important factor that always it is missing, and we found it through our studies, as people, they are usually missing reporting the other expenses. For example, the laptop that you are using for your analysis, the software that not only to train the machine, but also to conduct, for example, the reports. Sometimes there are workshops. The Noor, for example, project was done between scientists in France and also scientists here in UAE. We travel to France and we meet with them. They come here and they meet with us. So there is the flight also consumption, the emails, the video conferences, the power and the energy that you are using to conduct such a research also is an important element in the carbon emission that has been produced for the development of Noor language as a large language model. So of course, we have already released a paper about the holistic assessment and the energy consumption of the large language model. If you are interested about knowing exactly what is the average energy consumption that we take it into consideration to do our calculation, you can go through the paper in detail. But for Noor carbon footprint, we studied the storage and the transfer cost. The experimentation, how much we consume from the energy from our processing the data, curating the data, filtering the data, what is the best tokenizer that we can use, that it will have the least impact, and also still we have the good high quality data that we need to process and train for our large language model. And then the training, how many hours we use to train the model. Of course, because when you train the model, you can train it once as a testing model, then maybe you are not satisfied with the performance, then you have to try it again. For Noor, we have a different model size. We have from 10 billion. Also, we consider also the small scale modeling to analyze the performance of the model. So all of these GPU node hours that we consider and we consume in the computational budget for Noor, all of it, we consider it in our analysis and to report the exact carbon footprint. Also for the inferences, so far for the inferences, we didn't run, we run Noor internally. We didn't release it publicly yet. So the number of the inferences, always it's related to the number of token. And in order to give a fair or accurate reporting for the carbon footprint, we assume the same number. For GPT-3 model, OpenAI, they are using 4.5 billion words per day for their inferences. So we consider the same number. It will be used for Noor, and therefore you can see if in per day you can generate 30 tons of the carbon emission for only serving the model, not the training and the development and the research that has been done, but for serving the model itself, which is very important. And no one from and there is a rare community who are reporting the inference carbon footprint and neglecting this part, which is very important, because whatever you have been developed, you develop it for once, but once you train it and the model is accurate, many of people, they will use this model in different application, and the impact for the carbon and the emission and the energy consumed in serving this model, it will be huge comparing to the actual training budget. The other also expenses, we already consider it. What are the personal laptops, how many emails, and the operational cost from energy and power, the international cooperation, because we have this project is built based on collaboration with our another scientist from France. So how many round-trip flights between Abu Dhabi and France, and we calculate everything in detail in order to give you an accurate reporting for Noor carbon footprint. So in summary, what is the total energy consumption for Noor? But I would like to highlight, it is not only about Noor. Everyone has to do it for their own large language model or any AI revolution or algorithm they propose for the community to use. You can see here in the chart that 65% we use it for training only the model, and 30% has been used only for the development and the storage and the flights. And this part, the 30% is it has been neglected, and no one is reporting this one. Maybe only a few members and scientists they are reporting this one. So what are the best practices and recommendations that we can take from today is we can let's say better impact for the AI in the carbon emission. How we can have green AI. When I say green AI, how can AI provide you with a solution with a minimum carbon emission? So we can start with the modeling and engineering. For us as scientists, and maybe also the industrial people who are working on developing or integrating AI in their robotics and in their machine, what is the best optimal machine learning architecture I can take, considering the data size that I have, considering the model size, what is the trade-off that I can make, but still I have the good accuracy that I would like to serve for my clients. Also, we can tackle the efficient inferences through quantization and distillation. When I say distillation, for example, you can not always we can train large language model, but we can train a small model from the large language model. And then, for example, what is the efficient implementation? It is better to serve this model through the GPU or a different type of architecture in order to save the energy and the consumption that we are concerning about the energy consumption and how we can have sustainable ecosystem considering the environmental impact. At the same time, we can advance in the technology. And there is the fourth factor is there is no major discovery in the last year. So whatever we are trying to now in the large language model, we are trying to increase the size of the neural network and the size of the model. What about coming with a new AI algorithm that considering a small amount of the tokens, for example, I can serve the same number of the optimal performance considering a large number. So still we have, as well as an AI community, also to advance in this topic. From the hardware side, what are the best practices and recommendation, for example, for you as a scientist and a researcher, or for maybe industrial people, companies, they are working on the same subject? You have to select the right data center for you. You have to consider the high efficiency and low power usage effectiveness. You have to consider the energy mix that the data center is using, where it is located, because each country, they have their own energy mix. So you have to go and revise it and ask as well about the architecture of the data center. Also, you have to be considering some of the hardware that you are using and developing your product, for example, how it could impact the carbon around us, and minimizing the usage and the emission of this carbon intensity. We have as well, I said, we have to look through the electricity energy mix that significantly impacts the final footprint for your product. And then also from the hardware, also you have to select a tailored accelerator, AI accelerator, that when you are serving your model, you still have an efficient inference, but also you have a low carbon emission from your serving API. What are the other practices as well that we can consider to minimize the effect for the carbon emission from our AI algorithm? Is we can reduce, for example, if you are a researcher, we can reduce the international flight. If we are doing a collaboration with different universities, different institutes, different industrial partner, maybe Zoom is the, for example, we like today, we can use it as a solution. Also, we have to consider other aspect that we are considering in the research development. How many researchers, how in the lab that you are conducting your or manufacturing your product, integrating the AI machine, do you need to power all the machines or only that machine? So all of this you have to consider it as, and it is in fact included in the project that you are trying to integrate your AI algorithm or develop an AI algorithm and later integrate it in your product. So far, what we are lacking, as I stated before, we are lacking the cost reporting for the large deep learning model. In the literature, I highly recommend the AI community to start reporting the full energy consumption and the carbon emission for their project, considering as well the inferences, because other people, they will pick your AI algorithm and they will try to integrate it in their products. And then yes, it is maybe it serves the advancement of the technology, but still there is effect, and it has an effect and impact in the sustainable development goal and the carbon emission. So the main highlights from today that we can take it with us, that we are the first to conduct end-to-end assessments of the energetic and environmental energy bill for large language model in Arabic. We encourage the AI community to consider the data center as well efficiency, the supply electricity matrix for that data center, the location for the data center, where you are storing your data, how you can serve your model using the best accelerated AI. As well, just to put, for example, in perspective as a conclusion, we did the analysis for Noor, and Noor in total, this is only the production cost for Noor. Forget about the inference, because we didn't do the inference yet. We just get an estimate per day how much it will be. But just to the development of Noor project from end to end, it cost us 36.5 tons of carbon emission. And if you want to put this one in context, the average consumption for American emits 20 tons of carbon emission per year, which means that Noor is twice the consumption for that person that he can take for 1 year only. And then, for example, as a Swiss citizen, their carbon, the individual Swiss citizen, the carbon footprint emission for each one is around 11. And for example, if you compare it with Noor, it's similar to the 3 years equivalent for the carbon emission for a Swiss residents in Switzerland. So we have to consider, yes, we are going through the development of the AI. The AI in core, it is my main mandate as a director of the AI unit. We are integrating AI and developing AI algorithm in all the aspects and different domains to solve the challenges for even environmental and food. But we have also to consider the development of this algorithm and the impact, especially not only in the training, but also in serving this model and integrating it in the edge devices in the future based on the application and the sector. So my key message as a conclusion today is you can see, for example, if you do nothing, we will stay the same, but the small effort, it will give a huge impact and success toward having green AI, and we have a better tomorrow. We can ensure that with the advancement of the AI technology and the advancement of the technology in different sectors, still we can consider the environmental energy consumption with the evolution in the AI and different technology. Thank you.
Thank you, Ebtesam. That's an amazing presentation, and so I'm sure it's going to raise a number of questions. I have a few questions on this end. Before going to the questions on the content, I mean, it's obvious that this presentation has raised huge interest. Now I have to transfer a kind of a housekeeping question from Ushnish Sengupta, who is asking whether there is a link to a report on the topic by the Technology Innovation Institute. And I would broaden his or her question to a question on what's the path to publication of your work and presentations in congresses. So how are you going to kind of disseminate this wonderful work?
So the work and the Noor assessment, it's already there. You can go and type Noor, the holistic carbon footprint, and you can see the full assessment in detail and the number that we take it and the assumption in order to do the exact reporting for the carbon footprint.
Okay, so that's the answer to Ushnish Sengupta. I mean, this work may be accessed on your site. Now, before questions come from the audience, and I encourage all the audience to kind of type their questions and they will be transferred to us, have kind of a wrap-up question. What I take from your presentation is that AI in itself should not be a culprit for energy consumption, and the energy consumption of AI is not inherent to the concept of AI. So my question would be, where are we going to see more progress? You mentioned the progress on hardware and on the efficiency of hardware, and we've seen the efficiency on software, on all the process. So where do you see the most progress coming from, and in which time frame?
So it is a group work, in fact. So in order for us, for example, similar today for the sustainable and what is ITU and the UN, they are trying, we set already the sustainable development goal. But for us to achieve it, we have to collaborate with each other. For us, for example, some of the scientists, they have to come up with a new algorithm considering the optimal performance, but also less carbon emission. This is one community. There is another community, for example, like other companies, I don't want to mention them, but they are providing us with the AI accelerator, which we are using them for us for training this model. They have to develop a new or consider a new architecture in the hardware that we can serve or train the model, but also the lifetime and the energy consumption, it has the least impact in the environment. And there is, for example, the application. So the AI itself, maybe for me, I can deliver for you a new AI algorithm that you can use it to estimate the carbon emission in your manufacturing. But it will help you, for example, to have an efficient control for your manufacture, but still you are using my model. And the model, maybe it will cost more in terms if we are considering the whole. So just to show, in summary, it is a group effort from people who are building also the data center. They can consider what is the best country to develop and to build these data center, because for the people, they will use this data center to train and to also serve their model. So there are many aspects to consider.
And you've been extremely audacious and also, I would say, very profound in doing this work. But every, I would say, activity that has to deal with lots of data should do the same. So do you feel that the methodology that you have developed for really measuring the carbon footprint of what you do could be applied not only to the building of a large language model, but also to other research projects? I'm thinking, for instance, of clinical trials or AI applied to health. We see a number of projects which probably could have the same hygiene, I would say, mental hygiene as you have had on your field.
Yes, exactly. So what you said, now we are trying, and this is what we are trying to encourage the community, whatever project that you are working on, even if it's not related to the AI, but you have to report your carbon footprint from the developed algorithm. It's not necessarily to be linked to the AI and the data, for example, but also in a different domains.
Mm-hmm. Okay. And now I see a question coming from Ali of mine, who is kind of challenging your comparison of the energy usage of a person with the energy usage of AI. And basically what I get from the question is that he or she would be interested more in kind of what can we save with the AI? And so, I mean, how do we compare the cost, the energy cost of AI with what we can save of introducing AI processes into real life?
So this is a more general question. Of course, the AI by itself, when it comes because the human need it. Otherwise, we will not think about a new solution. So for me, for example, I meet a lot of customers. They have a need for using, for example, automated machine. They don't want to send, for example, a human for the research and rescue mission. There are some of the places that we need the AI, for example, or the robotics or the automated to take care of the elderly, because now, for example, I am I'm working on the office. So we need this developments in our life, and it is coming because we need it. And that's the reason you see the developments in the technology, because the human always we create it because we need it, we think about it, so we need to find a solution. That's why there is a scientist community, there is industrial community. We sit together and to fulfill the gap, and then we discuss what are the possible technology. So AI, there is a huge impact in our life in a positive way. In fact, today, for example, we can meet and we can discuss and we can share the knowledge with each other thanks to the technology and the advancement of the technology.
Thank you. Maybe you could tell us a word on how the UAE is maybe different in its approach. I mean, what I see as an observer from outside is that the UAE is investing heavily and very efficiently in building knowledge and luring highly talented scientists from both inside, you're an example, and outside to develop, I would say, computer science and mathematics and everything that has to do with those skills. And so could you tell us a little bit more about, I would say, the specific policy of the UAE authorities, who seem to be very intent on building a very strong scientific community in the Emirates?
So this is our main goal, and we want to transfer from the oil-based economy to knowledge-based economy. We have to have startup companies, ecosystem for the research and developments. We want to have the best people, not only Emirati, but also international. So it will be a global hub that everyone can come and to work on the research and developments. Of course, when you have this vision, they give us the trust to enable that vision. And you see me, for example, and different colleagues, for example, in TII from different nationalities, more than 61, they are all working together through this mission, because the effect or the impact that I will create here, it will have a global effect, similar to any work around the world. So there are different institutions or industry, they are working on something. For me, I have to refer to them, and then, for example, I can build on their knowledge. And that's why I believe that we are in a circle. And then UAE, we are going on the right track. We are equipping our national with the right skill, and we have it, and we just need to build the ecosystem, and we are in the right track, and we are doing it.
Mm-hmm. And yes, and I guess COP28 will take place, if I'm well informed, in UAE in 2023. So I guess is your organization TII going to play a role in this exercise?
Yes. So in fact, yesterday I was working on how we can propose some projects from TII and display it in COP28. It will take place, I think, in November. Next 2023. So in UAE, we are considering the global impact and the environmental impact and the advancing technology. As I said, it will play a major role to save the humanity and serve as well the humanity, but also we have to consider how we are developing and producing these technologies. So yes, you will see a booth for TII there in COP28, not only from TII, but different as well organization, because we have a lot of organizations, they are working on the advancement of the technology. We have Mohammed bin Zayed University of Artificial Intelligence as well. We have Khalifa University, leading university here in engineering. We have UAE University. So you will see different entrepreneurs, scientists, people, they are working there and presenting their project towards the environmental and sustainable ecosystem.
So that sounds really great. Well, Dr. Ebtesam Almazrouei, many thanks and congratulations for your presentation. Thanks for answering the questions. And I think we're now at the end of this webinar. So I'd like to thank the audience. You were, I think, quite a great number gathered around this exciting presentation. And if I understand well, there is now the possibility to do some networking on the neural network. So for those who are willing to go to the network, please enjoy the networking. Thanks to all, and all the best in your careers, in your research, and in your projects. Bye-bye.
Thank you, Jack. Bye-bye.
Bye, Ebtesam.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. After the networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.